Remember that the goal for today is for you to be able to use the distributive property to rewrite expressions using positive and negative numbers. And so we're going to continue using tape diagrams. And part of the reason I'm going to push you to use a tape diagram initially is that when you are faced with sort of more complicated word problems, tape diagrams are a really useful strategy to help visualize your thinking to then ultimately create the math sentence. So here we've got 4 different problems where we're going to draw a tape diagram to represent the situation. And so if I look in here, this first one says, each of 5 gift bags contains X pencils. Tyler adds 3 more pencils to each bag. And altogether the bag contains 20 pencils. And so for this one, I know that again, I'm going to just start by drawing it's a terrible box, but a box. And it says all together, so that's giving me a hint that that's the total, is 20. And it says each of 5 gift bags, so that means I need to divide this chunk into 2, 3, 4, 5 equal sections. I didn't do a very good job making them equal, but I should. And then it says they contains X pencils, so each bag has some number of pencils. And then Tyler's going to add 3 more pencils to each bag. And so I'm going to add in plus 3, plus 3, plus 3. If Tyler had subtracted 3 pencils, I would have written like minus 3 right there. And so now if I want to like write the math sentence that this is, what this is really saying is that I have 5 groups of X plus 3, and that total value is 20. So again, I like using tape diagrams as a way to help scaffold me actually building and creating this equation. Because if my ultimate goal is to solve this equation and to figure out what X is, the value of X is in any of these, having the structure helps me figure that out. And so I'm going to go through and create the tape diagrams first, and then we can go through and solve them. And so now we've got Noah drawing an equilateral triangle. So if it's equilateral and it's a triangle, it means it's going to be 3 sections. So I'm going to put a little 3 right here. With side lengths of 5 inches. He wants to increase the lengths of each side by X inches. So the triangle is still equilateral and has a perimeter of 20 inches. Okay, so I know that in total, that's a better box, that the perimeter here needs to be 20 inches. And this is an equilateral triangle. That means there's going to be 3 equal sections. And let's see here, the side lengths have at least 5 inches. And then he wants to increase the side of each side by X inches. And so I can write plus X, plus X, plus X. And again, that tape diagram really helped me visualize what the math sentence needed to be, because now I can easily see that there are 3 groups of 5 plus X, and that total value there is 20. For this third one here, we've got an art class charging each student $3 to attend plus some fee. It doesn't tell me what, so maybe I'll just put like an X there to represent that variable. Today, $20 was collected for the 5 students attending the class. So I know that the total, let's see here, the total amount, it looks like it's going to be $20. And I knew that it says was collected from the 5 students attending the class. So I know that this is going to be 20. And it tells me each student costs $3. And let's see how many students were in there. So, 5 students. So that means I need to chunk this into 5 equal sections. 1, 2, 3, 4, 5. And each student is going to pay $3. So everybody gets $3 plus some fee. We don't know what that fee is. So we're going to write in plus X in each of those. And now I can see that there's 1, 2, 3, 4, 5 groups of this 3 plus X equals 20. And then my last one here, make sure we can still see that. Yep. Now we've got Elena running 20 miles this week, which was 3 times as far as Claire ran this week. Claire ran 5 more miles this week than she did last week. So this one's a little bit more tricky for my brain personally to figure out, but I know the total value of running is 20. And let's see here, Elena is essentially going to be 3 times as far as Claire. So if I knew how far Claire was, I could multiply that times 3 to get me to Elena. So maybe this can represent Claire. And so Claire ran 5 more miles than this week than she did last. So however much she ran less last week, let's call that X. And then she ran 5 more of those. And so this is a good way. Again, this one was, for my brain, was the hardest to figure out how to draw the tape diagram or how to set up the equation, but drawing the tape diagram helped me figure out that I needed 3 equal chunks of however far Claire ran plus 5 to get to Elena. So now I've got these 4 equations, and if I want to solve them, again, there's 2 strategies I can essentially use to help isolate this variable. If I notice that I think it's 1 and 3, yeah, 1 and 3 are equivalent expressions. Ooh, this is parentheses in the wrong spot. 1 and 3 are equivalent expressions because I have 5 groups of 3 plus x, and here I have 5 groups of x plus 3. And then this one, 2 and 4 are equivalent because I have 3 groups of 5 plus x and 3 groups of x plus 5. And so we can use our inverse operations and our distributive property to help us solve it. And so remember, one way I can do that is to distribute this 5 in, to rewrite that as 5x plus 15 equals 20. And how I got that is 5 times x is 5x, 5 times 3 is 15. And so now I can use my inverse operations to isolate that variable. Since this is 5x plus 15, I need to subtract 15. And so I get 5x equals 5, because 20 minus 15 is 5. And now the math happening between that 5 and that x is 5. And so I get x equals 1 for that one. We can do the same strategy down here. Maybe I'll do the opposite strategy for this one. And so I can, instead of distributing that 5 in first, maybe I can think that this is 5 times 3 plus x. So the first thing I could do would be to divide both sides by 5. And so I get 3 plus x equals 20 divided by 5 is 4. And now I have 3 plus x equals 4. So in order to figure out x, I can isolate by using inverse operations. Since this is 3 plus x, I need to subtract x from both sides. I get x equals 1. So again, either strategy works, whether I distribute it in or I divide out first. We're just using those strategies to help isolate the variable. So starting with your scaffold of creating a tape diagram to then write your math equations to then solve your variable for your indicated variables. Distributing it in looks like multiplying whatever's on the outside in, or I can alternatively divide by that coefficient first out. Either way is fine.